Good morning, Swans and Falcons, and welcome to Maths. Today is Monday the 1st of February 2021, and this is our learning intention for today. Can I find the rule in one-step problems? Okay, so pause the video and get that written down, and then restart when you're ready to move on. Let's do a few warm-up questions then to get us going before we do the learning for today. So find 25% of 180, it's a bit of revision from last week. Write 9/100ths as a decimal. 3, how many sides does a hexagon have? And then work out that missing number problem there. So 9 times something equals 63. Again, pause the video and then restart when you're ready to go through the answers together. Welcome back. Okay, so the first one, we want to find 25% of 180. And we know that our percentage is out of 100. And there are, how many 25s in 100? That's right, there are 4. So there's 4 lots of 25 in 100. So to find 25% of 180, we could divide 180 by 4. Or if that's easier, halve and halve again. So half of 180 is 90, so half of that is 45. We could also have used a bar model to help us visualise that. So we could have drawn ourselves a bar model. So this is 100%, and then we can split it into 4. So I know that each of those sections represents 25%. So all of that together is 100, obviously, and then I know that 100% is 180. So 180 divided by 4 would be 45. Hopefully that makes sense. Next, we have 9/100ths even as a decimal. So thinking about our place value, which column is the hundredths column? And it is this one here, isn't it? So hopefully you wrote 0.09. How many sides does a hexagon have? I always remember the letter X to help me remember, because hexagon and heptagon, I get a little bit muddled. But if you think about the letter X being in hexagon, in 6, and also in hexagon, it reminds me that a hexagon has 6 sides. And the last one here, 9 times something equals 63. So 9 lots of something is 63. So 63 divided by 9 would be how many? It would be 7. So 9 times 7 is 63. I can use my fingers to help me. So 7, put that down, 63. Okay. Right, imagine I'm a garage. Well, I'm not me personally. Imagine I own a garage, and primarily I replace tyres on cars. And I know that most cars, unless you have a 3-wheeler, which are not very common nowadays, most cars have 4 wheels on them. Okay. Now I'm a business that replaces tyres, and I've got cars coming in, and I need to know how many tyres I need to order for those wheels. Okay. So if I had one car coming in, I would need 4 wheels, wouldn't I? What about if I had 2 cars coming in though? How many wheels would I need? I'd need, 8, wouldn't I? Okay. And what about 3 cars? I would need 12. Can you see a pattern emerging here? What's the difference? What am I adding on each time? I'm adding on 4 each time, aren't I? So then the next number must be 16, mustn't it? Add on another 4 for 5 cars, it must be 20. What happens here though? Because I'm not going up to 6 cars, I'm now jumping up to 10 cars, okay? So on Monday I might have had 5 cars come in to have their tyres changed. On Tuesday I might have 10 cars booked in. Now do I want to go, right, 6 cars I need 24 for, 7 I'd need 28, 8 I'd need... If I had to do that because I had lots of cars, that would take me a long time. So as well as looking at the pattern here in this sequence, I can always look at the pattern here as well to see if I notice a pattern. And what do you notice each time? Let me change the colour to orange. So each time I'm multiplying by 4. So 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. So that means I don't have to go, right, 6 times 4 is 24. I can go straight to 10 times 4 is 40. 15 times 4, well, 2 15s are 30, so another double that again is 60. And then 4 times 100 is 400. So if I had a very successful business and I had 100 cars, or I'm just very efficient at changing tyres, 100 cars coming in, that would be 400 that I would need. And I wouldn't have to go through 79, 80, 81, each one in turn to calculate it. Okay, this is called a function machine, okay? And a function machine, I put something in, there's a function, so something happens to that number, and then I have an output, okay? This is the previous question represented as a function machine. So these are my numbers. I'm inputting the number of cars. My function is timesing it by the number of wheels, and my output will be the number of tyres that I would need for that number of cars. So 1 times 4 is 4. 2 times 4 is 8. We know that 15 times 4 is 60. And 100 times 4 is 400. Okay, so whatever my function is, that's what I do to that number, and sometimes it might be adding, it might be subtracting, it might be dividing, it might be timesing in this, like this example. Have a go at these ones here and see if you can work out either what the output is. Sorry, I should have written that at the top. So we've got input and the output. Oops. See if you can work out what these missing numbers are. Pause the video, have a go, and then restart when you're ready to move on. Okay. So this first one here, I have 10 that's going in. I've added 5, not times by 5, added 5, it's been a long week. Added 5, and my output, 10 plus 5, that's right, is 15. Okay, this one here, 12. Not adding this time I'm timesing by 3. So 12 times 3 would be what? That's right, 36. Oh, now this one's a bit trickier. This one's a bit trickier because I had something I put in, I divided that by 9, and out popped 8. Okay, so something divided by 9 equals 8. What could that be? Now, if I'm working back the other way to work out that missing number, I'm going to do the inverse, the opposite, the inverse. So what's the opposite of dividing? That's right, it's timesing. So 8 times 9 is 72. So I can easily work out missing numbers by using the information that I have here. Okay, remember, if I'm going this way, I'm going to do the inverse, because 15 take away 5 equals 10. 36 divided by 3 equals 12. Okay, hopefully you can see that pattern emerging. Like this one, I've got 3 inputs and 3 outputs, and this here suggests to me that the function is the same for all of those. So what could that function be? What have I added to 1 to get 6? I've added 5, haven't I? So maybe my function is plus 5. Does that work on the others though? Because 3 plus 5 is 18. Not 8, not 18. So it can't be that, can it? And 10 plus 5 is 15, not 60. So it can't be that. So that cannot be my function for this problem. So what else could I have done to the 1 to get 6 other than adding 5? The other thing I could have done is multiplied it by 6, couldn't I? I could have multiplied that by 6. So let's see if that works for the others then, the other inputs. So 3 times 6 is 18. Yep, that works. And 10 times 6 is 60. That works. So that must be our function for this problem. So what would the input be if the output was 72? So if the number over here was 72, what would the input be? And remember what I said, we're going this direction, we're doing the inverse, aren't we? So 72, not times 6, but divided by 6. So 72 divided by 6 equals, how well do you know your times tables? It equals 12. And we can go back the other way, 12 to double check, times 6 equals 72. Okay, what I want you to do now is pause the video here and have a go at the worksheet for me, and then come back when you've done that, and there's going to be a problem solving task for you to do online, okay, on the video. Okay, welcome back. So I have this problem here, okay? I have a number and I input it into my machine, I multiply it by 2 and I get an output, okay? But I've forgotten what my number is because I'm so forgetful, you know what I'm like. I've forgotten what my number is, but I do know 3 facts about my number, okay? I know that my number is a factor of 32. I know that it's a multiple of 8, and I know that it's a square number, but I can't for the life of me think what that number was, so I really need your help to work that out. So pause the video, have a go at working it out, and then come back and tell me what my number is, please. Okay. Right, welcome back. Let's see if we can work this out together. So we know that it's a factor of 32. So let's try and think of all the factors of 32. We know they come in pairs, don't we? So let's work out our factors of 32 over here. So we have factors of 32. They come in pairs, 1 and 32. What are the other factors? So 2 and 16. Is 3 a factor of 32? No, because 30 is in the 3 times table and so is 33, but 32 isn't, so 3 can't be. What about 4? Oh, 4 is, isn't it? 8 times. 5 can't be because it doesn't end in a 0 or 5. 6, no, because 30 and 36 are multiples of 6, so 6 can't be. 7 can't be, 8 we already know, so I think we've covered them all because 9 isn't, 10 isn't, 11 isn't. Okay, I'm pretty sure we've got all the factors of 32 there. So I've got the factors of 32. I know that my number is a multiple of 8. Okay, so what numbers here out of these factors are multiples of 8? Well, we have 32, isn't it? Because 4 8s are 32, 2 8s are 16, and 1 8 is 8. So I've now got my 3 numbers. I've narrowed it down to those 3 numbers. What's my other? So I've done that one and that one. My last clue is a square number. Can you remember what a square number is? It's a number where it's the product of a number that's been multiplied by itself, isn't it? So we have 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is, look, 16. There we have my, let's jump up to green. This one here is my square number. So it satisfies all of these things. It's a factor of 32. It's a multiple of 8 and it is a square number. So my input must be 16. So if my input is 16 and I've times it by 2, what is my output going to be? Have a think. That's right, it's going to be 32. Okay. I'd like you to have a think and see if you could come up with a similar problem to this to post on your blog and challenge some of your classmates to answering it. So can you come up with an input and come up with some different criteria and see if some people can help you with your memory like you helped me with mine. Thank you very much for that. Anyway, I hope this makes sense. Have a go. Let us know on the blog if you had any problems and then we will help you get your head around it. And it's been good to see you today. I look forward to seeing you tomorrow. Take care. Bye.